you have started working on the problem which I had given in the previous class, right? Fine. So, Swati, can you show me what workout that you have done?
No, sir, I didn't see the question.
Swati K. Punit Kumar GP. Punit Kumar GP. Sachin,
Yes, sir.
have you worked out?
Sir, I don't know if it's correct, but I worked it out. I got it like A10 A bar 00 A.
Are you telling from the left hand side?
Yes, sir.
You'll have to work it out. Can you show me how you worked out?
1 minute, sir. I'll show it. Minute, sir. I'll show it. Can you see, sir?
Let me just make it big. It's actually, okay, let's see, it's not bad. How have you taken 0? Okay, A bar is fine, A is fine. And then the cell values, how have you taken?
Sir?
Cell values?
Like
Cell
I
values
took
are
it
very
in
important here.
horizontal.
Cell values, taking the cell values are
took it.
very important here.
Yes.
Okay, so cell value has become wrong. Fine, you can try it out, no problem.
Yes.
Okay, you can turn off your video. Siva S. Siva S.
Yes, sir.
Yes. How you have to work out? Can you show me?
1 minute.
Yeah.
Can you see, sir?
Siva S. Just a moment. So your answer is A10. No. See, what all of you are doing is you are not properly writing the cell number. Okay, fine. Siva, you can turn off the video. Okay, so what is happening is you are not writing down the cell number. Writing the cell number is very important. Okay, let me just
Sir, can you explain that again, sir?
yes, I will.
Okay.
Okay, so you are able to see my screen, right? All of you. Visible, right? Students, can you respond?
Yes, sir.
Okay. Fine. So here we will take this example only. Okay. Implement the following function with ABCD. Okay. And summation 0, 1, 3, 4, 8, 9, 15. So what I will do here is as our previous example. Okay. What had happened in our previous example, I taken A as my input, right? So A was taken as my input. Okay. And I go with 0, 1, 2, 3, 4, 5, 6, 7. How am I getting this? As I told you previously, okay, this is just like A. Okay, so consider this as A. Okay, and this one as B and C. B and C. Okay, so you will have to use for I naught, B and C will be what? 0. Right. So it is like 0, 0, 0, 1, 1, 0, and then 1, 1. So here I will be using for A bar it is 0 and for A it is 1. Okay. So try to see these, you try to match these. Okay, in that way it's going to be helpful. Okay, so try to match these alone. Okay, so I have 0, 0, 0, which corresponds to what? 0. Right. Similarly, I have 0, 0, 1, so it corresponds to what? 1. So now you are able to understand how we are getting this. Yes. So you have to see that row and column. So let us take this one. Okay. So A is what? 1, 1, 0. So which means what? 6. Isn't it? So in this way, we are going to actually value or put the numbers inside the implementation table. Students, are we clear with this concept? Please respond. This concept is clear? How we are numbering the table inside?
Yes, sir.
Yeah? Okay, fine. So if this is clear, then we should be able to continue with our problem that was given. Okay. So whenever, one small trick I will tell you, whenever we are taking the first parameter, okay, A as our input, it will just continue. The values will continue towards, the from left to right, okay, in the ascending fashion, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is one trick. Suppose I'm taking C, okay, say here I took C, okay, so in that way, I'm going from top to bottom, 0, 1, 2, 3, 4, 5, 6, 7. So that is one easiest way to remember. But behind the screen, what is happening? As I explained, with this table, you have to work it out, because suddenly I might then take B as your input and take A and C as your select lines. So in that way, you should be very careful. Understood? Okay. So here we are taking A bar. One of your friends had made a mistake. He had, the student had taken A here and then A bar at the bottom. So if you do that, uh, it's a mistake. So always start with A bar, 0, and then 1. Okay, so we are just highlighting 0, 1, 3, 4, 8, 9, 15. 0, 1, 3, 4, 8, 9, and 15. So these are highlighted. So as per the rule, if both are circled in the same column, now just see along this column, 0 and 8 both are circled. So if both are circled, it will be a 1, right? If both are not circled, then it is going to be a 0. If one of them is circled, then you will have to see across the row as to which one it is. So this is corresponding to A bar. So A bar, I bring it here, right? So you understood? And here also you see we are using with respect to I4, you see only 4 is highlighted, so that is A bar. None of them are selected, 0. None of them 0. Only the lower one is selected. So I look at the row which is A and I bring A here. Any doubts, students, still here? Still here, any doubts? Because we're going to have problems based on these types of implementation table. Any doubts, you can ask me. Are we clear to this point? Yes, are we clear till this point?
Yes, sir.
Yes, fine. So moving on, what we do now is we take these inputs and we put it across my mux. Okay, the same order is maintained from LHS to RHS. Same order should be maintained. Okay, so whatever numbers are going from left to right, the same thing comes from top to bottom here. Okay, so this should be maintained. So I have 1, 1, 0. So 1, 1 is given, 0 is given to I2. I3 is A bar. A I have here going through an inverter. So I get A bar, right? So I3 is done. Similarly, I4 is also connected because these two are connected where? To my inverter. To my inverter, right? And similarly, I5, I6, these are connected to 0, to this point, right? Okay, so I5 is done, I6 is done, right? Now I7 is what? A. So directly I take from here. From this point, I take my I7. So the remaining, now since I've taken A as my input, right? So B, C, D are going to be my select lines. So this is how you are going to implement using mux. Fine, students, can we proceed with the next concept? Any doubts here? Any doubts, please ask with the implementation or with the table. Is it all fine? Yes, can we move on to the next concept?
Yes, sir.
Fine, okay. So our next discussion point is going to be adders and subtractors. I think I have taken a section of adders, right? And I have explained. But nevertheless, what we will do is let us go in a flow, and we will again see few concepts about adders and subtractors, right? So I think you would have even seen this in your basic electronic classes, right? And Adding two single bit binary values produces sum and a carry out. Okay, so I will always have a sum and I will have a carry out. This operation is called half adder because I have just two single bits, and the circuit that realizes the function is called half adder circuit. Adding two single bit binary values with the inclusion of a carry input produces two outputs, sum and carry. The circuit is called full adder. Suppose I increase the numbers. Two half adder circuits can be combined and it can be made a single adder. Okay, so that is called your full adder, right? So what I have done here is x, y. So this is my inputs, sum, carry. These are my outputs. Okay, so just have a look at this. Have a look at these truth tables. Okay, so this is your adder. I think you have seen this, right? Last time also, and this is going to be just a kind of revision. Okay, fine. So full adder, what is going to happen? You have x, you have y, and you have c. Okay, three inputs, and I think you know how sum and carry are getting generated, right? Any doubts in how we are determining the values of sum and carry, students? Okay, fine, Surya, thank you. Next, we get the truth table, okay, for half adder and full adder, and correspondingly we can have the equations. How do we get equations? Wherever we have high, okay, wherever high values are there, so those will be taken. For example, here it's going to be 1 and 2. Okay, so sum will be a function of x and y. Okay, function of x and y, 1 and 2. Similarly, your carry has one high value that is corresponding to 3, so 3 will be here. Okay, and we can even write the equation here, okay, with respect to sum. Okay, wherever we have high value, okay, so it will be the opposite. Okay, so x bar y and y, x bar y and x y bar. Okay, so that is our value, or we can even put it as x as XORed with y. Then C out, okay, high value I get when both x and y is high. So which means it is equal to x and y. So once we have these equations, it's easy for us to implement. So I can use this direct implementation. X is XORed with y and get a sum, and C out is x and y, right? X and y, I get C out. And the other way that you can also do is, you can take xy bar, then x bar y, that is without XOR gate, okay, x y bar. Okay, y passes through an inverter, I get y bar. So x and y bar gets multiplied, I get x and y bar. Similarly, x bar and y both are added. Okay, I get sum. Then both x is actually connected here, x and y both are multiplied, I get C out. So this is an alternative way of implementing just without the help of XOR gate using basic gates. So if I mention in the question using basic gates implement a full adder, then this is going to be your answer, and with the help of XOR, it's going to be as simple as diagram A. Okay, right. Now for full adder, okay, for full adder, this was for your half adder. Now for full adder, okay, we are going to have 3 inputs, and the values are going to increase here, right? We are going to get from 000 to 111 combinations, right? And the similar fashion, I get 1, 2, 4, and 7 high values, 3, 5, 6, and 7 for C out high values. This one can be even implemented using K-map. Okay, so for some, I will put 1 wherever the values are, okay, and for carry also I will do this. Here I cannot have any group, right, because these ones are far away, so there is no group, so I will have to use the same thing. So which means it becomes x is XORed with y and XORed with c. Similarly, your C out is going to be xy, okay, then yc in, then xc in. So I hope now, by now you will know, or you should know, how these equations we are getting, right? You all know how we are getting these equations, students? Students, you're clear how we are getting xy, yc in, and xc in? Okay, fine. So any doubts, you can always feel free to stop, and you can ask me questions, right? So if you're not asking any questions, then I assume that you are understanding. Okay.
Sir, after this class, can you share this PDF?
Yes, I will be shared. It will be shared, but the only thing is, if I share the PDF, okay, your writing will not happen. You will just keep this as reference. Understood? Cyan, come up on unmute and come up. Cyan, can
Yes,
you
sir.
unmute? Yeah.
Yes, sir.
See, that is one downside of me, sharing the notes. You understood, right? Unless
Yes,
and
sir.
until you write it on a paper and you practice, it doesn't happen. Okay. Now, if I share my notes directly, what's going to happen? You will just see that, okay, and you will understand. But that is not important in our subject. Our subject is 50% understanding and 50% practicing, right? So I want you to refer to the video and see from there and write out. That is why every day I'm sharing the links to you.
Okay, sir.
So we could also refer to the PDF and write it down.
But how sure I am that you are writing?
So you could ask us for our notes.
Oh, is it? Fine, that can be done, but I think so that will not work out 100%. Correct, Lokesh? Maybe some of you might. So it's a mix of all, isn't it? So that is why I always prefer sending notes at the end of the module. So what do you all say?
So if we have notes now, we can easily practice.
Okay, fine. So we will look into it. No problem. Okay, fine. So this is how you actually use your K-map. Okay, and you can get these equations, and you have your sum equation and your carry equation. So you can even implement it. This is from another author. As I told you, I refer about 7 textbooks, okay, for your subject. So this was from another author, and I found it a little interesting. So I thought I will put it up on the notes and discuss with you all. So x bar, if I take it from here, it's going to be x, right? So this is another way of implementing. So taking everything, whatever I want towards my left hand side. Okay, x bar, y bar, c in, then x bar, y, c in. How do I get it? I get through these functions here. Okay, through these equations here. So once I have it, okay, directly use my AND gate, and to combine them, to add them, I will use a sum, okay, OR gate. So that was another way of implementing. I think this one we have discussed, right? Have we discussed this concept? See out xy plus x in plus y in, how we are going to minimize this. Okay, so for the benefit of everyone, you can just listen to me. I have xy plus xc, okay, and since I want a y here, what I will do is I will have y plus y bar, because that is going to give me 1. Multiplying this with 1 is not going to harm the values of x and c, right? So then adding with y and c, then I want x parameter here, so I will add x plus x bar. So xy plus a normal multiplication happens, xyc and xy bar c, okay, then xyc plus x bar yc, fine. Then I common out things, I take xy, then 1 plus c, okay, and I keep those remaining terms as it is. Then xy 1 plus anything becomes 1, and anything multiplied with xy remains xy. So this whole term is xy plus xy bar c plus x bar yc. Then here you will have xy, then common term is c, so I will have x bar y plus x bar xy bar plus x bar y. So that gives me our XOR function, right? So I will have xy plus c into x is XORed with y. So this is how you have to use your Boolean algebra, and you can actually reduce an equation. Okay, fine. So using XOR gate, okay, your function, okay, xy, okay, if you see your sum equation here, x is XORed with y and XORed with c in, right? So using your XOR gate, it's going to be very simple. X is XORed with y, and that is again XORed with c in, right? So I get the sum. So for my c out, I will have to use the help of AND gates, xy, xc, yc. Then I get my c out, right? Okay. Now, if suppose I ask you a question, okay, using 2 half adders, okay, and an OR gate, okay, construct a full adder. So this is going to be your answer for that. Okay. So you can see these dotted lines that I have done, right? So this is going to be your single half adder. Okay. So here, what is the output? X is XORed with y. Okay, and here it is xy, right? So do we have the same equations here for our half adder? See, x is XORed with y, and carry out, c out is xy. So we have the same. So this thing, this whole thing is actually taken here. Okay, and I'm using another one here. Okay, so I'm using 2 half adders and an OR gate. Why do I need an OR gate? Because I have to add 2 things. Okay, 2 final things from the first stage, and this is from my first stage, and this is from my second stage. So first stage output from the AND gate, and second stage output also from the AND gate. So totally I combine them both using my sum or using my OR gate. So students, are you clear with this as to how we are using 2 half adders to construct a full half adder, full adder?
Yes, sir.
Okay, fine. So what you can also do is you can individually put equations here. X is XORed with y, then xy. Then here you can take this x is XORed with y and c in. So which means x XORed y, and that whole thing is XORed with c. Okay, it should be c in actually here, right? Then you have your AND gate. This output here, second stage. and first stage output. Combine them using your OR gate. Okay. So we will be getting xy plus c and x is XORed with y. The same equation that you can see here. The same equation which we had implemented for our full adder. Okay. So using two half adders and an OR gate, I can construct a full adder. Okay. So similarly, now we can make use of this binary subtractors. Okay, just like how we have adders, we also have something called subtractors to minus out values from one to the other. Okay. So half subtractor does not have a borrow input. Full subtractor has a borrow, just like how we have carry. Okay, C in, and here we have B in. B in is borrow in. Okay. So B is difference and B out is your borrow out. Fine. So 0, 0, 0 minus 1. 1 is the difference. 1 minus 0. 1 is the difference. Okay. 0 minus 1. Important here. It is actually minus 1. So difference is actually 1 and borrow is also 1. Then 1 minus 0. It is actually positive 1. So 1, there's no borrow out. 1 minus 1 is 0. Borrow out is also 0.
So how did you take a borrow?
Hmm?
We don't have anything, right?
Have anything for?
So 0 minus 1, how do you take a borrow?
0 minus 1 is what? Mathematically minus 1, right? Right? Hello?
Yes, sir. But
Yeah.
but how
So-
do you take a borrow?
So in that case, that is the rule. Just like how we add 1 plus 1, 1 plus 1, we're getting 0. I mean in adder, right? And carry gets generated, right? We have that rule, isn't it? See, look at this truth table. Look at this truth table. I have 1 and 1. So when both are added, what is happening? I'm getting 0, carry 1. C out, carry out. It's going to the next level, right? So similarly here, this is happening for adding, and that happens for minusing. So here, since it's a negative 1, so what is going to happen? 0 minus 1, 1, and that minus is actually taken as borrowed. Understood? Okay.
So for minus, we could have kept one more bit to show if it is 0, it is plus, if it is 1, it is minus.
We can do that, but we are just discussing a simple subtractor here, right? We are not discussing any complex circuit here, isn't it? So for a simple subtractor, we just have x, y, borrow in, borrow out, difference, right? So this is how the rule is. Okay. Then we have 1 and 1. So 1 and 1, we minus, so get 0. There's nothing borrow out. Similarly, the same thing you can look in for your full subtractor as well. Okay. See here in this case 0, 1, 1, 0 minus 1. 0 minus 1 is actually what? 1 and 1. Now again that one you're minusing with 1. So it gives me 0. Understood? Lokesh?
Yes, sir.
So again you're minusing that remaining 1 with 1. So 1 minus 1 again becomes 0. Previously it was 1. Only if you take this case, okay, only if 0 and 1 if you take, it is 1. But again you minus with one more 1, then it gives me a 0. Borrowed remains as it is. That borrowed is because of 0 minus 1, not because of 1 minus 1. Okay. Similarly, 1 minus 0 is 1, and then 1 minus, again, this 1 and 1 will get cancelled out. So I get 0 and 0. Right? So I hope these values are clear for you, students. Any doubts with these values as to how we have got them? Is it clear? Is it clear? Can I move on to the next concept, to the next explanation?
Sir,
Yes.
sir, can you just explain that differentiation part once again?
Okay. So D is here, right? So 0 minus 0, 0, 0 minus 0, 0, 0 minus 1, 1 and 1, because it is a minus 1 there, right? Because we are minusing what? A lower value. Can I minus 1 from 0? Can I
No.
minus 1 from 0? Not possible. So I need to borrow. I need a borrow there, right?
So, sir, whenever it is 0 minus 1, we need to give a
Exactly.
borrow.
Exactly.
Okay.
Borrow is easy.
Okay, sir.
I borrow, then I minus, then I'm able to minus. So which means, see, it is just like this. You want to buy something, you don't have money, you take it from your friend, and then you buy it, right? So friend here is your borrow.
Yes, sir.
Okay. Next,
Okay.
1, 0. I think that is clear. 1 minus 1. Okay. Here you see now this 111 case, you see 1 minus 1 is what? 0. Then 0 minus 1, again I'm getting the same case, right? I'm not able to minus 0 minus 1 is actually 1, and I take a borrow. Is it clear?
Yes, sir.
Okay, fine. So now that we have developed your truth table, so next is your functions, right? So wherever I have I, x, y, so I take it for 1 and 2. Similarly, my borrow out. Okay, so I think you know how we get the outputs, right, for B and B out for the respective inputs, and accordingly we actually look into the functions here, okay, and we get this. So this results can also be simplified, okay. So here directly if I can see it's going to be x bar y plus xy bar for the difference, right, and for the borrow it's going to be x bar y, okay. Similarly for your half subtractor, just have a look at it. Yes, please tell me. Okay, so according to the equations, right, so you will have your borrow and difference. So difference here, again we are going to use an XOR gate, x bar y and y x bar, and then your b out, okay. Similarly for full subtractor, okay, the same concept, we can put them in the summation form, okay, min terms form. and using k-maps, okay, we can simplify them and get these equations. So this is going to be my final circuit, okay, for my difference and borrow out, which is full subtractor because I have x, y, and borrow in. Okay. So any doubts here, students, with regards to the subtractor? I hope it's pretty simple, right? Any doubts here? Okay, so yeah, thank you, Surya and Sagar for responding. Now, once you have the equations, directly you can just use your logical gates and you can get this implemented. Fine. So in the next class, what I will be doing is I will be showing you as to how to cascade them. Okay. Now how to use more, okay, x0, y0, and x3, y3. How to use more, extend the capabilities of. So this is called a cascading for full adders. So we will see this in the upcoming class. I think we will stop here. Okay, and we will continue the sessions in our next class. Okay, right. Thank you.